All right, let's take a look at 1-47. Decide whether each of the following situations represents a proportional relationship. Explain why or why not. Well, what needs to be true for something to be proportional? First of all, it needs to go through the origin, 0, 0. And the other thing is that it needs to have constant growth. For each unit, it needs to go up the same proportionally. So, which creates a straight line. Kareem is ordering video games. Each video game costs $39.99 and there's a $4.85 shipping charge per order. How much will it cost him to order any number of video games? Well, if we put this on a chart, it would cost him $4.85 no matter what, and he only pays that once. And then each video game is going to cost $39.99. The more video games he buys, the more he pays, but he only pays that $4.85 once. So that would be a no. All right, let's take a look at the next one. A given rectangle has an area of 20 feet. What is the length for various widths? Well, let's make a chart and see. If the width is 1, the length is 20. If the width is 2, it would be 10. 3, and whatever 20 divided by 3 is, so I'm going to stick to numbers that are factors of 20. 4 and 5, 5 and 4. If the width is 2, the length would be 10, and then you have 20 times 1. In this case, if the width doubles, the length doesn't double. In fact, it splits in half. Here, this doubles and this splits in half. If this splits in half, this doubles. So this is not going to work. And also, it can't have a width of 0. You can't multiply 0 times anything to get 20. All right, let's take a look at the last one. Oleg ran 8.8 miles in 1 hour 20 minutes, assuming he continues at a constant rate. Well, right there it tells you it's going to be proportional because it's a constant rate. And then the other thing is, if he runs 0 miles, how much time has it taken him? 0 time. 8.8 miles in 1 hour 20 minutes. If this doubled, this would also double. So I would say this one is proportional.